Hi, welcome to this lecture on inheritance and polymorphism. It's again an interesting concept in object-oriented programming. So before I go over the lecture slides, let me take you to the whiteboard where I'll discuss some intuition behind it, and then I'll revisit the lecture slides, and we'll do some demo also in the process to understand this concept. So what is inheritance? Alright, so here in inheritance, we will be looking into the organization of our program. So here, it all depends on the problem domain. And from the problem definition or the problem domain, we'll think of organizing the program in such that we'll have a class hierarchy. Okay, so we will be dealing with some relationship between the classes. So let me give you an example first of all, and then from that example we will develop this concept. So here conceptually we may not have just one class, we'll have more than one class. So here we'll have the notion of a parent class. So you can call that class as parent class or superclass or base class. So these are the three names that we give to a class which we'll call as a parent class. And then we also have something called as the child class or subclass or the derived class. So that's the concept behind inheritance. Well, we will be using inheritance when there is a case of inheritance. Okay, so we'll take the example where we see some inheritance and we will exploit that. And when we are doing inheritance, we'll have the concept of the parent class, which is also called the superclass or the base class, and then we'll have the other class which will be called child class or subclass or derived class. Now let's think of some example where we might have this kind of a scenario. So the first example that we have in our lecture slides, so let me stick to that. So here we are taking the example of the common pets that we have. So what are the common pets? So you would agree with me, the common pets are, let's take the two most common, dog and cat. Right? So let's take a very simple example and try to see that if somebody is asking us to write a program which will deal with the objects of type dog and cat, then yes, we should start defining our dog class and cat class, and then we should use these two classes to create the objects for dog class and the objects for cat class. Now before we even start doing it, what we should think here from inheritance point of view, we should see that do we have anything common. Okay, do we have anything in common in these two classes, dog and cat? So if you think about it, then you will find sufficient commonality. Alright, so in our example that we have in the lecture slide, these are very simple, but those are sufficient to understand inheritance. So what is common in between dog and cat? First of all, they both are pet. So we will not keep that information like both are pet, but let's get more specific. Let's try to find out something which is more specific, which is common between dog and cat. So you'll say that they are both mammals. Okay, they are both mammals, they both make sound, right? So dog has a specific sound, cat has a specific sound, but they both make sound. They are both mammals, they both have fur, right? They have fur. So you can think of these common behaviors. Alright, so in these two example classes like the dog and cat, we can think of common behavior. So wherever you have an example scenario where you can find the commonality between the classes that you're designing, you have the case of inheritance. So how will this inheritance work right here? In this case, rather than just creating two classes like a dog class and cat class, what we should do, we should create a parent class. Okay, or parent, super or base class, which should be a mammal class right here. Alright, why mammal class? Because cat is a mammal, dog is a mammal, right? So our parent class should be the mammal class. And then what we will do, we will create subclasses. All right, so in this example we have two subclass. What are those? Dog subclass and cat subclass of the parent class, which is mammal. And this is the symbol that we use, an arrow. All right, and this is also called is a. Why is this called is a? It is called is a for the reason that if you try to understand what is dog, then dog is a mammal, cat is a mammal, right? So what is happening in this case? In this case we have three classes. Mammal class, which is our parent class, dog class, which is one subclass, or the child class, cat, that is another child class. So we have three classes here involved in our problem. One parent class and two subclasses. Okay, so that is one example of inheritance. So let's have a look at another case where we can have inheritance. All right, so let me give you another problem, and let's start thinking about that problem in terms of classes and hierarchy and inheritance, hence the inheritance thing. If I say that let's write a Java program where we will have two classes, right? So we will use those two classes to create objects. So what should be the classes or the objects like? We should have student class, so that I can use the student class to create instances of student class, which are student objects. And let's also think about another class which we will use to create the object for that different second class. We'll call that employee. All right, so now whenever we have to solve a problem which involves inheritance, we should first list the data members for each class. Okay, so for the student class, again this is an example that I have in my lecture slides, so I'm discussing that, and anyway we will have more systematic discussion on that through the lecture slides. But I believe that this helps when I work on the whiteboard. So for the student class, let's think about some important data fields that we will keep for a student. So you'll agree with me that the student should have name. Okay, we can also think of ID, but let's leave ID field. Let's make it very, very simple. Student will have name, will have age, and being a student should have a GPA. All right. Now, when you have to create a class for employee, then you should think that, even the employee should have a name. Okay, an employee will have age. An employee will have salary. This is a very simple example. You might think of more attribute of employee. You might think of the department of an employee, designation of an employee. That is fine. But for this simple example, which we are using to understand inheritance, I believe this is sufficient. Alright, so when the problem domain is given to you, then from that you will look at the classes and you then try to find out the common data fields or common behavior between these two classes, and you should use that common behavior or common property to come up with the parent class. Okay, so if you're looking at these two classes like student and employee, then from here you're getting this hint that the student has these two data fields which are name and age, and similarly for employee also we have the name and age. Okay, so now in this case we can exploit inheritance. We don't want to repeat these information for two classes, right? Because that is duplication of the information. Alright, so if you don't use inheritance, you'll have name and age field for student, name and age field also for employee. Okay, so which is duplication. And what we should do here in this case, where you find common properties between these two classes, we should think of creating a parent class. Alright, so using this commonality, we should think of a parent class. So what could be a parent class? Person. Alright, so the person should be a parent class, And for person, we will define person class with the data fields like name and age, because that is something which is common in between these two classes. And once you have defined person class, then you can derive these two subclasses from the parent class person. What are these two subclasses? You have the subclass like student, and then you have the subclass like employee, and we will use the same symbol. Okay, this arrow symbol, which stands for is a relationship. So is a relationship is between student and person. Student is a person, employee is a person, but student and employee, these are more special classes. Okay, so there's another notion of generalization and specialization. So when you move upwards, right, so we can move in two directions. We can either go up or we can go down. So let's think about our upward motion in a hierarchical, in an inheritance hierarchy. This is an inheritance hierarchy. So when you move up, right, when you're moving from student to person, then student is more specific case of a person class. Why more specific? Because student is a person who's studying, so the student has GPA, okay, an additional data field which is GPA. So student is more specific person. Similarly, employee is more specific person class because it has another additional data field which is salary. Alright, so this direction, when you're moving from person to employee, you are getting more specialized, and when you're moving from student to person direction, then you are getting more generalization. So this is called generalization when you're moving up in the hierarchical in the inheritance hierarchy, and when you move downwards from the parent class to the subclasses, then this is called specialization. Why specialization? Because the class that you had, which was the parent class, got more specialized as you moved downwards. Okay, so I think this much is sufficient to get some intuitive idea behind inheritance, like what is it that we will try to model. Okay, so this kind of relationship we will try to model through our programs. And how do we do that? We will be doing a demo for that. Okay, so with this information, let me take you to my lecture slides. Alright, so here we have inheritance and polymorphism. Polymorphism is a slightly more advanced topic which will come in the next lecture. In this lecture, we will be confining ourselves to inheritance only. Alright, so the same example, right? Cat and dog, but more systematic here. So if you look at cat and dog, put cat on the left hand side, on the right hand side put dog. Let's see what are the common properties between cats and dogs. Cat is a mammal, so is dog. Dog is also a mammal. Cat has fur, dog has fur. Cat is a common house pet. Same is the case with dog. Cat has several breeds, so is the case with dog. Right? So these were the common behavior. Now, how are cats and dogs different? Cat makes a different sound. Right? This sound is different from the the barking sound which dog makes. So right here, these points that you have are the differences between these two classes. Okay, so when we have to think about the class hierarchy for inheritance, we need to keep in mind similarities as well as differences. So top four properties are similar. The remaining properties that you're finding will make cat a specialized class for mammal class. Okay, cat makes a different sound. Cat has this feature that cat scratches furnitures, catches mice. Dog barks. A dog can catch frisbees, chases squirrels, and can guard a house. Okay, so let's take this simple example and try to develop our understanding of inheritance. Good. So now, with the same example of cats and dogs, let's try to understand what will we be doing in inheritance. So from these two classes like cats and dogs, what we have to do, we have to find out the common properties that these two classes have. And using that common property, we will define a parent class like the mammal parent class. Okay, so some classes they share properties that are similar, and then the same is the case with cats and dogs. Both are mammals and both are common house pets. So what we will be doing, we should create a parent class like mammal, the way I created in the whiteboard. And what's the advantage? Why should we do that at the first place? Because we don't want duplications in our program. We don't want to write the same code at multiple places, because that is not considered a good programming technique. Okay, and what we are learning to write object oriented programming, where one of the advantage is that it helps us in reducing the duplication. Okay, so how can we achieve this here? By using inheritance. Alright, so what we should be doing, we should abstract out common characteristics. I like this term. We should abstract out common characteristics between the classes, if it is possible. In some cases it may not be possible, but for cats and dogs it is possible, right? We saw a lot of common properties between these two classes. Good. Now this is a nice diagram if you look at. So here mammal is our ultimate parent class. Then from mammal we have two subclasses, cat and dog. Okay, so cat is a mammal, dog is a mammal. Alright, fine. So this much I was able to draw in the whiteboard at this level. Now this inheritance hierarchy that you have, it can go further down. I had only two levels in my whiteboard, level 1 and level 2. But in this figure, you can see that we have three levels, right? What's the third level? You would agree with me that cats, they have a lot of breeds. So cat has Persian breed and Manx breed. Similarly for dog, we have poodle as well as collie. Okay, so this thing is applicable in inheritance programming also. In the problem that you're solving, you might have different levels of inheritance. Okay, and yeah, if that is the case, you'll have to write your program in such a way that you're taking care of those different levels of inheritance. Good. So I like this example, right? And we have three levels of inheritance. Good. Now what is an inheritance thing? So the same thing which we have learned, let's give some definition and try to understand what we have understood with the help of some definition. Now what is inheritance? Is a mechanism by which one class acquires or inherits the properties from another class. So which is this class that is inheriting the property? The class that inherits the property is called the base class. Okay, and the class from which we inherit the properties is called the parent class. Okay, so in inheritance we have notion of parent class as well as the child class. The parent class will inherit the properties, the child class will inherit the properties from the parent class. And what are these properties? Data as well as the methods. Okay, now good. So it's a mechanism by which one class, so here I should have written the base class, acquires or inherits the properties, which means both data fields as well as methods from another class. Which is the another class here? That's the parent class. Good. So now what is a superclass? The class being inherited from is your superclass. That means in the example that we had, a mammal is the superclass. Okay, because these two other classes that we have, the dog and cat, they are the derived classes or the child class, and they will inherit the properties from the superclass, which is the mammal class. Okay, now the derived class is specialized by adding properties specific to it. Okay, so for this concept, it will help if you could think about the second problem that I had. The second example was about the employee and the student. So we figured out that when we have to create two classes, one for employee and the other one for the student, then we thought, for student we'll keep name and age and GPA, and for employee we'll keep name and age and salary. And then we had the parent class as the person class, and then from that we derive the classes like employee and student. So this employee and students are more specialized case of the person class. Why? Because student means a person who's more specialized. Student has one more data field than the person. What is that additional data field? That's the GPA. Similarly, the employee also is more specialized because the employee also had an additional data field in its class, which is salary, right? So in this process of the inheritance hierarchy, as you go down from superclass to the subclasses they tend to get more specialized. Okay, so that's what we have here. The derived class is specialized by adding properties specific to it. Okay, good. So it will get, we'll understand that even better when we start looking at the program. Alright, so from the program when you write, you will understand what do we mean by specialization. How are we making a class more specialized as we go down in the inheritance hierarchy. Nice, good. So what do we have in this slide? In this slide, we have the different names that we have given to the derived class and superclass, right? So on the right hand side, if you look at, then we can call the parent class or the class from which we are inheriting as the parent class or the superclass or base class. All these terms means the same thing. Okay, that means a class which is higher up in the hierarchy, inheritance hierarchy. And what's the derived class called? Now the derived class can be either called as child class or subclass or derived class itself. And how are these two classes related? By a relationship which is called is a relationship. Okay, so we saw that on the whiteboard I was trying to explain to you what is a there. So dog is a mammal, cat is a mammal. Okay, that's the relationship between the dog class and the mammal class, cat class and the mammal class, which is a relationship. Similarly, you have the is a relationship between employee and the person. Employee is a person and a student is a person. Okay, so that's what we mean. An object class that is derived from another class inherits its instance variable and methods. Okay, so that is the advantage. Why are we doing inheritance at all? Because we want to reduce the duplications. So how do we reduce the duplication? By keeping the common properties between the classes at the parent class level. So if we have some data members and the methods which are common in two classes, then we'll create a parent class and we will define those common data members or data fields and the common methods at the parent class level. Okay, so that's what we do. And using the inheritance, the subclasses, they will inherit those properties from the parent class. This will make more sense as we start programming. When I do the demo, I'll explain to you what do we mean by that. Good. So now any instance variable or method that is inherited by the subclass, we do not redefine again. Okay, so for that example, like when we had the person, student and employee, these three classes involved in inheritance, then in the parent class, which is person class, we will keep the data members like name, age and the related methods, whereas at the level of the student, we will only define GPA as the additional data member. We will not redefine name and age at the level of the student. Similarly, we will not redefine name and age at the level of an employee because those two fields are already defined in the person class. Anyway, we are inheriting that. Similarly, if we write some methods related with these two data members at the level of the person class, and then we don't need to redefine that in case of the derived class. That's what we mean right here. An instance variable or method that is inherited by a subclass does not need to be redefined. Nice. Now you might be wondering, like, why should we use inheritance? What's the advantage behind it? So the advantage is that, we may not have to reinvent the wheel. So a lot of classes are available to us from JDK. We have been using some classes. We started using scanner class, then we used string class, and then we used math class. A lot of methods in the math class we use. Then recently I introduced you to the classes like random class, date class. So similarly, we have a lot of classes available from JDK. Now for our application, we may just need to slightly modify the existing classes that are already available to us by JDK. Alright, so for those cases, we just need to slightly modify the existing classes either available by JDK or maybe from someone else. Then inheritance helps. What we need to do, just customize the classes which are already available. And these classes should be similar to what we want to do. Then only it will make sense to customize. And in a lot of cases, it is possible to customize. Alright, so we should know this trick of inheritance. Like, how can I create my own class which is based on a very useful class which is already available in JDK? So what I need to do, just customize that class so that I can use that for my own program. Alright, so that customization is a big advantage. So we don't have to rewrite the code, right? We will use whatever has been already written and tested, and I'll only add those things that I need, which is specific to my needs. Use methods and variables which are fully tested in the classes, and superclass code can be used in any number of subclasses. Okay, that is again an advantage. And as and when you do more programming, you will understand what we mean by all these things. Now, there's another very interesting advantage that we have in the case of inheritance. So now, when you have this inheritance hierarchy and there you want to make some change, right? Let's go to the case where we had the student, employee, and person. Now, if we you have written a program and the need changes, right? It's a very simple program, but there's something that got changed in the specification. So we define the student with the information like name of the student, age of the student, and then we have to add another field in the student class, which is we want to add the ID as well, right? Similarly for the employee also we want to add ID as well. So now if you have inheritance, then we don't need to make changes at the level of the student and at the level of the employee. We just need to make change at the level of the person, right? So that's what we mean. Wherever you have to make changes, then it is possible by using inheritance that we make change only at one place, right? For our example, if we have to add the ID field, then we can add that ID field in the parent class, which is the person class, right? So that will make the life a lot easier. Alright, so changing common properties is easy. Just change the parent class. Just add the ID field in the person class and we are good. Great. Now, that was about, maybe some theory, maybe some concept. Now we need to learn the trick. Right? We spoke too much about what is inheritance, how do we use that. Now we have to learn how to write the program involving inheritance. Okay, so let's look at the syntax, like how will you create a subclass. Okay, so very soon I'll start doing the demo, so you'll understand what I'm doing, and in the demo I will highlight these things, these syntaxes, like how to use it. Now in the syntax that you're looking at, we are creating a subclass. Alright, so for parent class we will not change anything. The parent class is to be written the way we have been writing parent class. Only the subclasses that we create need to use a different syntax. So what's the syntax for a subclass? Let's assume that our parent class has the name parent class and the child class that you are creating has the name child class. So how do you create a child class? which is derived from the parent class, well, you have to use this keyword which is extends. So how do we use that keyword? You will say public class. That's something we have been using for all the class definition. Public class, the name of my child class, which is child class here, and this class extends the parent class. Right, so using the extend, you will tell that the class which I'm creating here is a subclass of an existing class. Alright, and after that you can define your child class, but be careful. In the child class, we usually don't redefine those common data members that we already have in the parent class. In most of the cases we don't, but in certain cases we do. So when we do it, we should be careful about it, like why we are doing it. Alright, so when you do that, when you have declared your child class using this syntax, so what will happen? Now this child class will inherit all the instance variables and all the methods that were defined in the parent class. Okay, so by using this keyword extends parent class in your class definition, it will ensure that you are doing that inheritance. You are getting the common data fields from your parent class. Okay, so now is the time when I should take you to the demo, and we will be using the simple example dog and cat. Alright, so this is something I will use. Mammal would be our parent class. Then using the parent class mammal, we will define subclasses like dog and cat. I will not do dog, I'll do cat, but the same thing applies to dog as well. So let's go to Sublime. So what do I have here? I already created some empty Java files. Okay, so I have the test mammal. That is where I'll be writing the test program. And let's start with the parent class, right? So we should not have any problem here. I should say public class mammal. It should be capital. Public class mammal. And what do we have in mammal? We have boolean has fur. Alright, so I'm making it as similar as possible to the example that we have in the lecture slide. We can add more features, right? But let's keep it very, very simple so that we get this concept of inheritance. And for that reason, you should observe the fact that I'm not using private, public, or anything else. Since I'm leaving that default, which means it is package private. We'll get into that later. Maybe let's not pull everything in there, right? Let's just understand inheritance for the time being. Okay, so for mammal, I'm defining a mammal as a breed that has fur. Okay, so fur is the property or the data member, and I'm declaring that as boolean, which means you can set that as true or false. A mammal can have fur or cannot have fur, right? It's a boolean thing. And let's define one data member, which is make sound. Okay, so at the level of the mammal, so this is something that you don't have in my lecture slides, but I like putting it there. System.out.println. When you are at that level, when you are at the level of a mammal, which is a very abstract animal, you can't say what kind of sound a mammal will be doing, because a mammal could be cat, mammal could be dog, or mammal could be anything else. So what I like putting here, I would say unknown sound, because you don't know which mammal I'm talking about. Okay, so I have just two members right here at the level of the class mammal. The first is the data member, which is has fur, and then I have one method as well, which is what sound this mammal makes. Good. So mammal has been defined. Probably we would like to check the mammal. So what should I do here? Mammal m is equal to new mammal, new mammal. Alright, and I should say m dot make sound. Alright, and now I will try to run this program. I should say Java C. Okay, good. And then I'll run this. Unknown sound, right? So it worked. I didn't do anything great. Alright, just created a mammal class and tested that mammal class, and fortunately it worked. Now is the interesting part, where we have to derive a class from mammal. So how should I define this derived class? Say public class cat. This is how we used to do, right? If I create public class cat, then that is just a class which is independent of mammal class, and mammal class is my parent class. So how do I connect this? How do I make this inheritance happen? I should say public class cat extends, this is the important keyword, extends mammal. Alright, good. So what should I do here? Well, now I should talk about something which is specific to cat, right? So mammal has fur, that's fine, mammal has fur. So I mean, we had this data member like has fur or not, but that already exists at the level of mammal. So anyway, since since the cat is inheriting from mammal, so I have that data member in the class cat. Okay, so let's add some boolean has clause. Okay, so has clause is another data member that we may add to the cat class, and this is specific to the cat. And you can also add another data member which is for color. Alright, so I'm trying to recollect what features do we have in the lecture slide. Okay, so I'm putting these things just on the basis of my memory, like probably these are the data members that we have defined in the lecture so I'm putting the same thing right here. Okay, and now I'll do something which you might not like, you might get confused, but I'll try to explain why I'm doing that. So these are two data members which are specific to the class. Now I'll do something which is interesting, and I'll explain why I should do that. I will write this method here, make sound. Alright, and what I will be doing, since it's a cat class, it should be making the sound of a cat. Alright, so what did I do? Well, I redefined, you know what happened? I already had make sound method in the mammal class, but I was not happy with the make sound of the mammal class. Why? Because this doesn't make sound of a cat. So what I should do in my class, which is cat class, I should redefine this method. Okay, I should make sure that the cat is making the sound of a cat. Alright, so what I am doing here, it is called overriding. What I am doing, I am overriding the method make sound which exists in my parent class. So this is an interesting concept for which we have discussion in the lecture slide, but I thought that I should introduce you with what I am doing in my demo as well, right? So what I did, I redefined this method which is make sound in the cat class, which is subclass of the mammal class. Okay, and I'm making sure that the cat is making the sound of cat. Okay, good. So since we have made this cat class, we should check that class right here. I should say .out.println mammal sound. Okay, why mammal sound? Because you will see this make sound which is being called for mammal. I should do something like that for cat as well. Cat sound, right? But before I do that, I need to define cat. I need to create a cat object as well. So how do I do that? Cat. Alright, and I should not call m.makeSound because that will invoke the make sound method of the mammal. Rather, I should say c.makeSound. Alright, let's try this program now. Let's see what went wrong. Cat C is equal to cannot access cat. Why is that happening? You have public class cat extends mammal, and you have this thing right here, cat C is equal to new cat. That should be fine. Let me see. Bad source file .cat.java file does not contain class cat. Okay, let me see. This is cat.java. I should save this thing. Probably I forgot to save this. We will try this thing again. Line number 7. Public void make sound. Java. Public class. Okay, sorry about that. It should be capital C. Okay, yeah, these things can happen. Sorry about that. It was small c, so for that reason it was messing up. I hope I fixed that. Great. And now what should I do? Let me just run this Java test memo. Okay, cat sound, right? So it's now making the sound of a cat. Now the interesting thing is that you are using inheritance. How are we using inheritance? Well, we are defining cat in such a way that it is based on the parent class, which is mammal. Now, what can happen here? If you look at person, what is Persian? So Persian is a breed of a cat. So what I can do, let me extend my program and go further down. So when I'm defining a class Persian, here I should say, well, again, if you just define Persian, then this way, then Persian would be a class which will be independent of cat and mammal. But this Persian class that you have is in fact a subclass of cat. Okay, Persian is a breed of cat. So that's how you should define. You should say that the Persian class that I have is a subclass of cat. So this is how you go about it. Okay, so here I think we have just one data member, which is color. Just a minute. Fur color. Okay, so this fur color that you have, fur color is equal to white. There are a few things that you may find strange right here, but there are explanations in my lecture slide. What I'm trying to do right now in this demo, I'm just making use of the extends keyword to create the inheritance hierarchy. So what did we do? Well, we use the same, what did we use? We already have this data member called fur color in the parent class, which is cat. Okay, but when we are at the level of the Persian class, which is a subclass of cat, we somehow know that Persian cats, they are of white color, right? So what is happening here in this case, this is an example of hiding. What is hiding? Hiding is a case where in your subclass, like here, you have the same name of the data member as you have in the parent. So the parent class for Persian is cat. Okay, so the class Persian extends cat. Cat is the parent class. In the parent class, you have the data member fur color, which is an instance data member fur color. And what you did, you used the same data member name in the subclass also. So whenever you do that, then this subclass data member will hide the data member that you have from the parent. Okay, so this is called hiding, which is different from overriding. Because what did we do in overriding? In overriding, we provided our own version of the method which already existed in the parent class. So we were overriding make sound method that we have in the mammal class by redefining our make sound method in the cat class. Now you might ask me, so can we do the same for Persian class? Yeah, why not? In the Persian class, we can have both. Both means what? We can have the instance of hiding as well as overriding. Should I override? Probably yes, if you know what kind of sound this Persian cat makes. Right? So on the basis of the information that I got in my lectures seems to me that the Persian cats, they make the sound hiss. All right. Okay, good. So yeah, uh, this is overriding. Overriding. All right. So what I will do now, since I have another class which is a person class, I should say Persian cat sound. I should call Persian, right? Persian is the name of the class, and here Persian. Alright, I should not say C, let me use P for that. The object P is an object of type Persian class. Now I can invoke the make sound for the Persian class. Let's see what sound Persian cat is making. Okay. Alright, so you can see that a mammal is making unknown sound, cat is making the sound of the cat, which is a little general at the level of the cat, whereas a Persian cat will make the sound that a Persian cat makes. Okay, yeah, good. So this demo was more or less to give you some idea about how to use extents. It's not truly using inheritance, because what we did, we were overriding the method which is make sound in all our classes. Okay, that's okay. We'll learn about it, like why did we do that. But there's something you might be wondering, right? Starting from the mammal class, you are creating the mammal class object, but we don't have any constructor. I did not write any constructor here, right? But I was able to create the instance of mammal class. Similarly, for the cat class also, I am not writing any constructor. Similarly, for Persian class also, I am not writing any constructor. So what is happening in this example? In this example, I am relying on the default constructor. So for all my classes, whether it's a mammal class, cat class, or Java or Person class, for all these classes, I'm using the default constructor which Java provides, right? So I don't have anything inside that. So that's the default constructor. This is default constructor here, and here also have the default constructor. So again, please try doing all these things. Follow me. If you want to follow my video lecture, try that. Pause the video lecture and do it yourself and see is it working or not. That's the best way to learn programming. Okay, back to my lecture slides now. Okay, so we were on, I think probably I have, yeah, I was right here. So the same thing, right? So what do we have here? Well, all the code that I was writing in different class file, which ideally you should be doing, we have that in one slide. Mammal class has been defined, which is your parent class in this case. Now from that parent class, here you did not have anything in the make sound method. That's perfectly fine, you can do that. Then using this mammal class, you created a subclass called cat, and you'll be using the keyword extends mammal, and it has clause is a new data member which you're adding, and you should see that we did not have has clause in the parent class. So this is this data field is making cat more specialized mammal. A mammal that has another feature which is about a clause. It has a clause or does not, we can define that. Not only that, we have another data member which is fur color. So fur color was not here, right? It just had one data field which is has fur or not. Okay, so cat class got specialized by adding these two additional data members. But what did we do with the make sound? As I explained you in my demo, we override it. right? We are overriding, look at it, right? So we are overriding the make sound method that exists at the mammal in the mammal class. Okay, yeah, so we have done that here for cat class. And how about Persian class? Now the Persian class is the derived class of the cat class. So we need to declare public class Persian extends cat, right, using the same syntax. And what do we have in the Persian class? Well, we are defining a data member which is fur color, but this fur color is actually hiding the fur color right here. I explained that right in my demo, and you will find more systematic discussion right here in this paragraph. So the Persian class inherits has clause from the cat, right? Has clause we did not define, we did not override that, so it will get it from its parent class, which is cat. So it's present here because you are inheriting from the cat class. From the cat parent class, it overrides the make sound method. So interestingly, in these two derived classes that we have, cat as well as Persian, we are overriding make sound methods from the respective parent class. And here the fur color that you have in the Persian class is hiding, right? The fur color will hide the fur color data member that we have in cat. So I have this definition of hiding and overriding in my next slides. All right, yeah, here you go. And this is important actually. I love asking questions on overriding and hiding because these are interesting, not difficult to understand. Okay, so let's look at the definition. I believe definition is the best way. Once you have seen the demo, let's see what definition says, and demo and definition will agree. When do we override? Override happens for instance methods only. What are instance methods? The methods which does not have static. Alright, so overriding will only happen for instance methods, just for instance methods. And how do we find out instance method? If you don't have static in the method header, then that means it's an instance method. Now, when will that happen? When an instance method in a derived class has the same form of heading, that means the signature also, as the instance method in its superclass, then the method in the derived class overrides or redefines the method in its superclass. Okay, good. And how about hiding? When will that be a hiding? Well, when a field in the derived class has the same name as the one in its superclass, or a class method. Class method means a method which is static. So when a class method in the derived class has the same form of heading, which means the signature, as the class method, which means the static method in superclass, then the field or the class will hide the corresponding components in the superclass. Okay, so this definition might be a little confusing. Let me try to make it simple. If you have the instance method with the same signature in the subclass as you have in the parent class, then that is overriding. And if you have the other cases like the data members with the same name as we have in the parent class in the subclass, then that is hiding. And also, if you have the same signature as you have in the parent class in the subclass also, but your method is static, then that is hiding. Okay, so only in case of instance methods, when we have the same signature as in the parent class, we'll have overriding. For other cases, like for class methods with the same signature in the subclass as we have in the parent class, it's hiding. For the data field also it is hiding. When you have the same data field name in the subclass as you have in the parent class, that is hiding. Alright, so let's see what is happening here. So you have a class, parent class, we are calling that example, public class example. You have two members that we can see. The first one is a data member, calling that letter, its type is character. Then you have a method, which is a static method, right? We are saying public static string is the return type. The name of the method is line is. Okay, then that's okay. And then you're creating a subclass. You are defining public class ext example. That means extended example, which is the subclass of example. It is extending the example, right? That means you are establishing the parent and child relationship, which is a relationship. And in the subclass, you are using the same name of the data member as you had in the parent class, right? Character letter. So now, for this thing, you should have thought about it, right? Think about it, like, what is it? Same name of the data member as we have in the parent in the subclass. So this is hiding. All right, this is hiding. How about this case? Look at these two methods, string return type, name of the method is same, line is, but it is static. If it was non-static, then that is overriding. But here, since you have static here, then hiding again. So in this example, for letter as well as for this method, right here we have hiding. It's not overriding. It will be overriding only when this is non-static and this guy is also non-static. So in both of these cases here, in this example, we have hiding. Excuse me. Okay, how about this case? You have character letter and the public string line is. You have string letter and then the public string line is. So we'll look at these two later. Let's figure out what is happening at the level of the data member. Okay, so this class is again ext example extends the example. That means ext example is a subclass of example class. So we do have the inheritance. Now, for the reason that these two data members have the same name, we will have hiding. Don't get confused by the data type, right? Here the data type is string, whereas in the parent class the data type is character. That does not matter. We have to look at the name of the data member. So as long as the name matches, like we have letter here, this is the case of hiding. Okay, the name matches. How about the method here? So the name of the method is same, line is. The return type is also same, which is string, and this is not static. All right, so this is an example of overriding. So in this example, we have one instance of hiding, which is at the level of the data member, and the other instance of overriding, which is happening at the level of the instance method. Okay, good. So now you have another example. Sometimes you'll find multiple definitions or multiple slides discussing the same thing, probably from different angles, right? I have those things, just it depends. You might like one versus the other. So overriding versus hiding, we override an instance method of a superclass by providing an instance method in a derived class with the same form of heading. Form of heading means signature. Okay, and what do we hide? We hide a data field of a superclass by providing a field in the derived class with the same name. We don't say the same name, same data type. We just say same name. All right, good. Now this is an interesting example where you will see the true inheritance, right? And this is an example which I used in my whiteboard also. So the point is, when should we think about inheritance, right? When should we think about organizing your classes using inheritance, and how should you do that? So what you should be doing, you need to look at the data, right? Determine what data do you need to store. For the same example, right, it's the example that I used. If you are being asked to deal with or create student and employee classes, you have to deal with the data. Then first you should list the data fields that you need. And so for student data, you will probably keep the name of the student, the age of the student, and then the GPA for the student. Similarly, for employee, you'll have the name of the employee, age of the employee, and salary. Right? So once you have come up with this data level information about the different objects and the classes you have to design for your program, then you should look at the common properties of these objects. So what do? Now divide up your classes by state. That means students and employees store different data, so make them into separate classes, right? So we cannot have one class which should have the student, which should be used for creating student object and also employee objects. That will not happen, so we should not do that. Anyway, we need two different classes, students and employee class. But there are something common, right? We do find that out of these three data members that we have in each class, we do find two data members which are common, like name and age. So what should we do when we find significant common data fields? You need to pool common data into a common parent class, like person. Okay, so for person, first of all, we should also look for the name such that it is more meaningful. It should look like a general class. So when you have student and employee, more general class name would be a person class. All right, so we'll name that as person because student is also a person, employee is also a person. So we will create a class like person, and that person class we will keep the common data, pool common data into a common parent class, which is person data. Okay, so for person you'll have name and age, and then you should use the other class that you have, the subclasses like student class and employee class, to specialize this class, okay, or to customize this class. So that's what we mean. Have a student and employee customize the person class. All right, great. So let's look at the implementation now. This implementation should take you a step further in understanding inheritance. Okay, good. So what do we have in the person class? You define public class person. Now we are adding the stuff that we have learned until now. We are enforcing data field encapsulation. How do we do that? By making data fields private. So the name of the person should be string and it is private, made private, right? That's what we have to do just to enforce the data protection. Great. Age is also private, it's integer. Good. So both the data fields are private, and we have the appropriate data types. Now we are using just one constructor here. You can add two more. You can write the no-arg constructor and another constructor which is taking the name as well as age information from the user. For some reason we have done it differently. We are just using one constructor that is taking the name from the user from the client program. Okay, so when you create a person object, you should give the name, otherwise it will not happen, it will not succeed. So you say public person. The argument that we need in the constructor is of string type, which is the initial name. And what will the constructor do? Age will be initialized to 0, and then the name would be initialized to the name which we are providing in our constructor. Good, that's fine. Then we have two getter methods, get name which will return the name, and then you have get age which will return the age. Now we have an interesting method here, set age. Okay, so what is the purpose of set age? Well, probably when we have defined the class in this way, we will create an object of type person class, and then it will set the age to default 0, and then we will set the age ourselves. We'll take one more step and we will invoke this method which is set age, and we will change the age of the person to the age that we know. We are not doing that in one shot. If you want, you can write a constructor for that which will have age as well as the age will be another parameter in that constructor. Now look at this age thing. It's very nicely written, right? So how are you changing the age? Well, for setting the age, right, since you have to just change the age, you don't need to return anything. Then the return type of this set age should be void. In almost all the cases, the setters have the return type as void. So you have public void set age, and this is the value that the user is providing, and we want to set the age of the person to the value that user provides. But look at this implementation. Actually, we are very careful, right? How are we careful? We will look at the value that you're passing on to us. If the age is less than 0, which is meaningless, we should not change the age, right? So if the age that you are asking me to be updated is less than 0, I will not take your request. I'll leave the age as 0. Only when the age is meaningful, which is higher than, which is positive, not negative, then I will set the age to the age that you want, right? So these are some precautions you can take in your setter method. Okay, so from outside the class, you cannot let any arbitrary operation being performed on the data member, because you have to enforce data protection. Alright, so this is an interesting case where we are not letting the user reset the age to some negative value. Okay, so these kind of things you can apply in your setup methods. Okay, and since the age is private, you cannot directly change that value from outside the class. Maybe in the test class, from the test class, which has to be a separate class. The tester method should be there in a separate class, not in the person class. Good. Fine. What are we doing here? Well, we are defining the class student, which extends person. Alright, so here we just need one more data field, because student is a specialized person who is studying, and so the student should have a GPA as well, which will show how well the student is performing. So you have private double GPA. Nice. Now we have a constructor, and this constructor is very interesting because you'll find a new keyword being used in this constructor. Explanation we will have probably in the next class. We'll be dealing with these keywords. Okay, so what are we doing in the student constructor? Well, this is also very similar to the constructor that we had in the person class. It's being defined only on the init name. That means only the name of the student is being accepted. We're not providing any additional information about the age of the student or even the GPA of the student. We are just creating a student object with the name. That's it. The other things we'll deal with the help of the setter methods. Good. So what did we do here? If you look at the super and init name, what we are doing here, we are calling the parent constructor. What do you mean by parent constructor? That means the constructor which we have defined in the parent class. That means the constructor that exists right here. Okay, so how do you define the constructor of student? Our definition of the constructor for student is having a call to the constructor of the person class, right? So now the point is, how do you call the constructor of the parent class from a subclass? Well, you do that with the help of this interesting, let me use pen here, right here, this is important. Okay, yeah, the super keyword. What is the super keyword? Super keyword is used to invoke the constructor of just the immediate parent class. Alright, so that's the reason we are doing it. And there is a rule. The statement that you have which invokes the parent constructor should be the first statement in your constructor. So if you're wondering, like, can I keep GPA and at the first line and the call to the constructor in the second line? No. The rule is that the call to the constructor, which is the parent constructor, should be the first statement in your constructor. Okay, so you cannot change this order. Good. So that's how you define the constructor for the student class. Then you have a getter method for GPA. Great. GPA is right here, so you can retrieve that. Now look at the set GPA method. So again, as we had the setter method in case of the person class, similarly we have a setter method for student class also, and we are very careful, right? So if our client program is asking that we need to set the GPA of the student, because by default the GPA should be 0 because the student just joined in our system, the student has to still register for course. When the student registers for the course, earns some credits, then that's how the GPA gets reflected. Okay, earn some grades for the courses that the student is taking. Now we will again evaluate, right, whether the input that we are getting from the client program for setting up the GPA is meaningful or not. So the GPA should not be negative, right, and new GPA should not be more than 4. Okay, that's how we have it, right? GPA should be a value between 0 and 4.0, and that includes 0 as well as 4.0. Okay, so if the value is in that range, well, interestingly, here we have new GPA less. Okay, so this condition we need to check. The new GPA should not be greater than 4. Well, we'll look at this condition later, but assuming if the condition is, no, that's fine, that's perfectly fine, sorry. So here this is the condition where the GPA is not in our range. Okay, so this condition, either the GPA is less than 0 or GPA is greater than 4, that means there's something wrong with the GPA, and so that is invalid GPA. And for invalid GPA, we will keep the GPA as 0. We cannot accept the new GPA. Why? Because either the GPA is less than 0, which is negative, or GPA is more than 4.0, which we do not allow. Okay, if either of these conditions are true, then we'll keep the GPA as 0.0, otherwise we'll update the GPA. Okay, so again, an interesting setter method. So now, well, what did we learn? This extend person means that the student inherits all the instance variable and methods from person. What were the instance variable? The name and age. Okay, what were the methods? Set age, right? Set age was the method. Okay, good. And what is it? Well, again, this highlighted thing means that you are running the person's constructor, the parent class constructor. Now the same thing can be applied to the second subclass, which is employee. How do you define employee? Class employee extends person. You added the data field salary. Okay, and you have written a constructor for employee also, the same way as we have done for student. And here also we are calling the parent constructor by using super keyword, super and then the name, right? It's very similar to the student class. Now you have a getter for salary, and you have written a salary in the same way. You are careful. When you have to set the salary, you are looking at the salary. Salary should not be negative, and salary should not be more than 400,000. Okay, so these are the conditions that we'll check when the client program is saying that let's reset the salary by calling the set salary method. We should be careful. We'll evaluate the new value. If that falls in the range which is allowed, then only we will set the salary. Okay, good. Now what do we have here? We have written these 3 classes, which are person class. Use that person class as the parent class. We created the student class, which is a subclass, and specialized person class. And then similarly we did create employee class, which is again a subclass of the person class, more specialized because we have salary there. Now let's use all those classes in a test program. People tester is the name of the program. More meaningful, right? So here, what do we have? We are creating some objects named Mo, Larry, and Curly. Now we should think about, what kind of objects are these? Mo is a person. Why? Because That's what we have as the type. You're saying person more is equal to new person, so you're calling the person constructor, right? So this object is of type person class, and you're providing the name of the person, most Sturge. Okay, student's name is Larry, and you're using the name of the student class. Student Larry is equal to new student Larry Sturge. Okay, similarly for Curly, Curly is an employee because that's the type of the class, and we are calling the employee constructor Curly Sturge. Good. Now let's see, when you have created these three objects of type person, type student, and type employee, then what all methods are legal here? Like mo.setAge, can I change the age of the object Mo, who's person, and although he'll be pretty old, which is 106 years, is that legal? Well, you need to think about it, right? And the answer to that is yes, right? Why? Because set age is a method which is defined at the level of person. Okay, so the person class has this method set age, so you were able to invoke set age method, and set age is public. It's a setter. You can set the age. Now the next question is that Mo, who's a person, can I change the GPA of a person object? Well, again you need to think, right? And you should be able to get to the answer that no, it's not legal. Why? Because GPA is the data member of a student class, right? Mo is a person. Person will not have any data field like GPA or salary. Alright, it has just two data members, which are name and age. So we were able to set the age, but you cannot set the GPA because a person is the parent class. It will not have those two data members like salary and GPA. So the last question is about salary. Can you change the salary of Mo? No, for the same reason. Mo is person who's not student or the employee. How about Larry.setAge 101? Can you change the age of Larry? Interesting. Well, Larry is a student, right? And student is derived from person. So it will have this inherited method, right? It will have the inherited method which is set age. It will have the inherited data members which is age and name. So is this legal? Yes, it is legal. Okay, because we have inheritance. Can I change the GPA of Larry? Yes, because Larry is the student and GPA exists for the student class. Now, can I change the salary of this Larry? No. Why? Salary is a data field which is not valid for student. Salary and set salary, these are few things which are specific to an employee. Okay, so we are not allowed to do that. How about Curly? Can I change this age for Curly? Yes, for the same reason. Why? Curly is a subclass of person, so Curly also has the age and set age properties. Can I change the GPA of Curly? No. Why? Curly is an employee. An employee won't have a GPA. Okay, but can I set the salary for Curly? Yes, you can. Why? Because Curly is an employee, and you can change the salary of the employee. Alright, so I believe I should stop right here. The remaining slides I will cover in my next video lecture. Thank you so much, and yeah, let me know if you have any questions. Yeah, take care. Bye bye.